Good day. Today I will tell you about energy-efficient liquid cooling system used in HPC solutions of RSC. RSC uses liquid cooling system as the currently most efficient cooling system. RSC's liquid cooling system enables maximum reduction of solution footprint. I will tell you about specific features of RSC's HPC systems using Joint Supercomputer Center system in Joint Supercomputer Center as an example. RSC's liquid cooling system has an internal and external loops. The internal circuit joins the coolant distribution unit with computing node. The external loop joins the CDU and an external heat exchanger dry cooler. This is an RSC's computing cabinet. We see 3 columns with powerful RSC's blade servers. 2 collectors to distribute the cooling agent over the computing nodes. Liquid is supplied from the CDU bottom up. The collector evenly distributes the liquid over the computing nodes. Each node has an aluminum cooling plate that contains flowing water. As you can see, the plate covers the entire heating surface, enabling dissipation of all heat produced by the computing node. This technology allows RSC to deploy ultra-high density, energy-efficient solutions. Liquid heated by the nodes is gathered in the receiving collector and moved to the heat exchanger inside the coolant distribution unit for heat transfer to the external cooling system loop. Maximum water temperature at cabinet entry is 63 degrees Celsius. This enables free cooling mode, even in countries with a hot climate, such as India or African countries. Liquid from the computing cabinet goes to the CDU, where heat exchange occurs. After that, the cooled liquid returns to the distribution collector of the computing cabinet over the closed loop. Here you can see a heat exchanger. Heat exchanger is the place for heat exchange between the internal loop liquid and the external loop liquid without a direct contact of 2 liquids. It also contains circulation pumps, which provide liquid circulation in the internal loop with preset parameters. The internal loop uses distilled water with added corrosion inhibitors and other components protecting circuit integrity. This is the power cabinet. It provides power to the computing nodes and the required infrastructure. Here's the automated power supply system. Power comes from a 3-phase network with a 380 voltage. Infrastructure of the external cooling loop. The circulation pump provides cooling liquid circulation in the external circuit. The pump has a frequency control system. Therefore, it consumes as much power as it needs to meet the current cooling requirements. If the load is reduced, the pump's workload also goes down. This results in reduced power consumption. You can see a dry cooler behind me. The cooler cools the water down in the external loop using ambient air. The cooler does not have a freon circuit. In essence, the cooler is a complex cooling grid with a fan. The only power-consuming element in the cooler is the fan itself. Therefore, the cooler consumes much less power than chillers of comparable capacity. Maximum power consumption of the cooler is less than 10% of its dissipated power.